Azure Storage is a cloud storage solution provided by Microsoft Azure. It offers scalable, durable, and highly available storage services for various types of data, including blobs, files, queues, and tables. Azure Storage is designed to handle large amounts of unstructured data, making it ideal for applications that require high availability and redundancy. In this presentation, we will explore how to perform operations on data using the appropriate software development kits, SDKs, provided by Azure. Azure SDKs are collections of libraries and tools that enable developers to interact with Azure services programmatically. These SDKs are available for multiple programming languages, including .NET, Java, Python, JavaScript, and more. By using Azure SDKs, developers can perform various operations on Azure Storage, such as creating, reading, updating, and deleting data. The SDKs provide a simplified and consistent way to interact with Azure services, making it easier to integrate Azure Storage into your applications. Before you can start using Azure SDKs, you need to set up your development environment. This involves installing the necessary SDKs for your chosen programming language, setting up authentication with Azure, and configuring your development tools. For example, if you are using .NET, you would install the azure.storage.blobs package via NuGet, set up your Azure credentials, and configure Visual Studio or your preferred IDE. Proper setup ensures that you can seamlessly interact with Azure Storage from your development environment. To perform operations on Azure Storage, you first need to establish a connection to your storage account. This typically involves creating a client object using the SDK, which requires your storage account name and access key or a connection string. For example, in .NET, you would use the Blob Service Client class to connect to a Blob storage account. Once connected, you can start performing various operations on your storage account, such as listing containers, uploading blobs, and more. Blobs are a key component of Azure Storage, used for storing unstructured data such as images, videos, and documents. Using the Azure SDK, you can perform CRUD, create, read, update, delete operations on blobs. For example, to upload a blob in Net, you would use the Blob Client class and call the upload async method. Similarly, you can download a blob using the download to async method, update a blob by re-uploading it, and delete a blob using the delete async method. These operations allow you to manage your blob data efficiently. Azure Files provides fully managed file shares in the cloud that are accessible via the SMB protocol. Using the Azure SDK, you can perform various operations on Azure Files, such as creating file shares, uploading and downloading files, and managing file permissions. For example, in .NET, you would use the Share Client class to create a file share, and the Share File Client class to upload and download files. Azure Files is ideal for scenarios where you need shared storage that can be accessed by multiple virtual machines or applications. Azure Queue Storage is a service for storing large numbers of messages that can be accessed from anywhere in the world. Using the Azure SDK, you can perform operations such as creating queues, adding messages, retrieving messages, and deleting messages. For example, in .NET, you would use the Queue Client class to create a queue and the Send Message Async method to add a message to the queue. Queue storage is useful for building scalable and decoupled applications where different components communicate via messages. Azure Table Storage is a NoSQL data store that provides fast and cost-effective access to large amounts of structured data. Using the Azure SDK, you can perform operations such as creating tables, inserting entities, querying entities, and deleting entities. For example, in .NET, you would use the Table Client class to create a table and the addEntityAsync method to insert an entity. Table storage is ideal for applications that require flexible data models and need to store large volumes of data. When performing operations on Azure Storage, it is crucial to ensure that your data is secure. Azure SDKs provide various authentication mechanisms, such as shared key authentication, Azure Active Directory, AAD authentication, and SaaS tokens. For example, AAD authentication allows you to use managed identities to access Azure Storage without hard-coding credentials. Additionally, you can use encryption to protect your data at rest and in transit. Implementing proper authentication and security measures helps safeguard your data against unauthorized access. Monitoring and logging are essential for maintaining the health and performance of your Azure storage operations. Azure provides various tools and services for monitoring and logging, such as Azure Monitor, Application Insights, and Storage Analytics. Using the Azure SDK, you can integrate these tools into your application to track metrics, log events, and diagnose issues. For example, you can use Azure Monitor to set up alerts for specific conditions, such as high latency or failed requests. Effective monitoring and logging help you ensure the reliability and performance of your storage operations. To get the most out of Azure SDKs, it is important to follow best practices. These include using asynchronous methods to improve performance, handling exceptions gracefully, and optimizing your storage operations for cost and efficiency. For example, when uploading large blobs, you can use the upload async method with parallelism to speed up the process. Additionally, you should implement retry policies to handle transient failures and use pagination when querying large datasets. Following best practices helps you build robust and efficient applications that leverage Azure storage effectively. Let's explore a real-world case study to understand how Azure SDKs can be used to perform operations on data. Consider a media streaming application that stores user-uploaded videos in Azure Blob Storage. The application uses the azure.storage.blobs SDK to upload, retrieve, and delete video files. It also uses Azure Queue Storage to manage video processing tasks and Azure Table Storage to store metadata about the videos. By leveraging Azure SDKs, the application can efficiently manage large volumes of data, ensure high availability, and provide a seamless user experience. In this presentation, we have explored how to perform operations on data using the appropriate Azure SDKs. We covered various aspects, including setting up your development environment, connecting to Azure Storage, performing CRUD operations on different storage types, and implementing authentication and security measures. We also discussed monitoring and logging, best practices, and a real-world case study. As a next step, you can start experimenting with Azure SDKs in your own projects and explore the extensive documentation and resources provided by Microsoft Azure. Happy coding!